Okay, let's take a look at number 11. If the integral from 0 to 1 of f is 2, the integral from 0 to 4 of f is negative 3, then the integral of 1 to 4, and notice immediately the change in bounds here, of 3f of x plus 2 is what? So we're going to have to do two pieces. First of all, I need to find the integral from 1 to 4 of f of x. To do that, we're going to use these two pieces here. So we'll use the idea that the integral from 0 to 1 of f of x dx plus the integral from 1 to 4, which is what we're looking for, of f of x dx is equal to the integral from 0 to 4 of f of x dx. Let's go ahead and put in these values. The integral from 0 to 1 is 2 plus the integral from 1 to 4 of f of x dx is what we're looking for, equals, and the integral from 0 to 4 is negative 3. Solve that equation, and we get the integral from 1 to 4 of f of x dx is negative 5. Now, we use the properties of integrals that says the integral of a sum is the sum of the integrals, so we can split that up into the integral from 1 to 4 of 3f of x dx plus the integral from 1 to 4 of 2 dx. Here, this 3 is what we call a constant multiple that slides right through. It pulls right through the integral from 1 to 4 of f of x dx. Plus, this here is a horizontal line. If you remember, we've seen a few of these. There's a few different ways of doing this. The way I like to do it is think of it as just so here's 1, here's 4. The function is the function 2, which is a horizontal line. So this is just a rectangle. The width is 3, the height is 2. So the integral from 1 to 4 of f of x, we found that up above. That's negative 5 plus 6. Negative 15 plus 6 is negative 9. Number 12, the graph of the piecewise function is shown above. What's the value of the integral of negative 1 to 9 of 3f of x plus 2? Very much like the problem we just did above. In fact, the function or this piece inside is the same thing. So we're going to do pretty much the same thing. I'm going to say the integral from negative 1 to 9 of 3f of x plus 2 dx. We'll combine those two steps into one. It's going to be 3 times the integral from negative 1 to 9 of f of x dx plus the integral from negative 1 to 9 of 2 dx. So we'll talk about this piece in just a second. Plus here, the width of that rectangle from negative 1 to 9 is 10 times 2. All right, let's move on here. So the first thing we need to note is that this area, which is underneath the x-axis, is negative. This area up here is going to be positive. So what I did was I broke it up into 3 sections. We have a rectangle right here. I have a triangle right here. And then we have this large triangle up above. So first of all, this first piece is going to be negative. The width is 3, the height is 1. Plus or minus, it doesn't really matter. Negative. This is 1/2. It's a triangle, so it's half base times height plus, and this last one has a base of 1, 2, 3, 4, 5, 6, and a height of 2. So I get negative 3 minus 1/2 plus 6. So 6 minus 3 is 3, minus 1/2 is 2.5, which is 5/2. So 3 times 5/2 is 15/2 plus 20, or we can call that 40/2 if we want. That way we get 55 over 2, which is 27.5. Which of the following integral expressions is equal to the limit as n goes to infinity of the sum from k equals 1 to n of the square root of 1 plus 3k over n times 1 over n? So this one here was a little tricky. First time I did it, I came up with an answer that wasn't even up here, which is fine, but not when it's a multiple choice question. So the way we want to look at this is, I'm going to look at just this inside piece here, is that this is 1 plus 3 times k over n. And then what we're going to do here is this entire piece inside is going to become my a plus k times delta x. And that way this delta x inside, this 1 over n, and this delta x outside here match up. At first glance, it looks like delta x is going to be 3 over n, and then we have this 1 over n on the outside, which would have to somehow account for. That's the way that I did it, and I may put another video up showing that way, but for now we're going to look at it this way. So this is my a value, and this is my delta x value. So delta x equals b minus a over n, so that's 1 over n. So b minus 0 is equal to 1, so b is equal to 1. So we're looking at an integral from 0 to 1, which means right off looking at these answers, a would have to be it. And then notice up here we have a 1 plus 3, and here is the function right here, or the x. So the square root of 1 plus 3 delta x. All right, let's take a look at 14, the integral of the cosine of 3x. So this is that u substitution. So in this case here, what we're going to do is we're going to let u be 3x, and therefore du is 3 dx. So the derivative of 3x is 3 times this derivative of x, this dx here. So what we can do is we can substitute in, this is the cosine of u. The problem is I don't have du here, I don't have this 3. So what we can do is we can introduce a factor of 3 inside as long as we balance it with a 1/3 on the outside. So now I have my du, and the integral of the cosine of u is the sine of u plus c. Go back and substitute in. My u is 3x, so I get 1/3 times the sine of 3x plus c. '15, again, the problem is we have a composition of functions here, so this is some sort of like chain rule. Maybe you could do something with the u substitution, which is like our anti-chain rule. It wouldn't work here because if u is x cubed plus 1, then du is going to have to be 3x squared dx, and we don't have a 3x squared. The 3 is not a problem. We could balance that with a 1/3, but there's no way to balance that x squared. So we have to come up with some other way of doing it. So the way we do it is to FOIL out x cubed plus 1 times x cubed plus 1. We actually square it out. So I get x to the 6th plus 2x cubed plus 1 dx. This is now just a polynomial, so we can use the power rule. So that would be x to the 7th over 7 plus 2x to the 4th over 4 plus x plus c. Looking down below at the answers, they pull the 7s out, so it's a 1/7 x to the 7th plus the 2 and the 4 cancels, and it leaves me a 1/2 x to the 4th plus x plus c, so that's b. And that takes us through number 15. So we'll finish off and then 16 through 19, and then we'll do the free response question after that.